Hi everyone. So in the last class we have seen about PVs and PVCs. Now let's see storage classes. These are used for dynamic provisioning, and previously which we have seen the PVs, when you are doing it manually, that is for the static provisioning. So whatever PVs, PVCs or storage classes, both everyone everything are involved in storage provisioning for your pods inside deployments or replica sets. So in these pods, which you will be using PVs or PVCs, basically these are the ones who are responsible for providing you storage. This is the claim, which is like part of a cake, right? Yesterday we have seen. So that PVs or what you will be involved in the YAML file of pods. So using this PVs only, you will request a storage class or a PVs. So internally the picture will look like this. How will storage class help in dynamic provisioning? I'll just explain you. So storage classes also have the same sections as of others like PV. Like it has a reclaim policy, and there is a storage provisioner as well. Everything is same, but there is an extra thing which is volume binding mode, and we'll see. Like if you want, you can check right away the Kubernetes documentation for storage classes. So I can tell you there are three main sections. One is provisioner, and the other one is reclaim policy. Like yesterday we have seen, it can be either retain or delete, and there is volume binding mode. So this volume binding mode, which can be either two types, as of what I know, is wait for consumer. It is wait for first consumer. This consumer is like a pod, okay? So, or it is immediate. Now immediate is the default one. If you don't mention volume binding mode, it is by default immediate. But if you mention wait for first consumer, what happens? As in the name only, it suggests that the PV will be created. Wait, we are creating a storage class. What is this PV and why is it coming in the middle? Okay, I'll explain you. So before that, you want to see about provisioner. This provisioner, right, it can have different options. It can have no provisioner, or it can be any other cloud related provisioners like AWS, EBS, or it can be GC pod, which is Google Disk, and it can be either Azure Disk also. So different cloud provisioners you can use. The importance of the cloud provisioners will come into picture because that is the place where you highlight the persistence of the data. Even though nodes are getting I'm sorry. So even though nodes are getting deleted, the storage just gets detached, and you can still attach the same storage even though you detach that volume. Okay, that is where the cloud provisioners come into picture. Now if you want to use this cloud provisioners, you have to mention under the provisioners of the storage class when you are creating that YAML file. Okay, it's just like instead of PVs, you create a storage class, and if there is this cloud provisioners, right, it automatically create a PV inside your node for you. Automatically it will spin up. The thing is, the storage classes will be talking to the provisioners and ask for okay, I need this much amount of storage that is requested by the pod. Let's say the pod is requested some 216 mi of storage. Okay, so and this much amount of storage will be provisioned for or 256 mi, right? So anything that will be provisioned by the storage class via a provisioner, and automatically when the provisioner is giving that particular storage, it will automatically spin up a PV for you, so you need not manually create it, and it will automatically create it for you. That is one advantage. And they ask in the questions like scale up or scale down the storage, that is, or dynamically you have to provision the storage, means you have to use a storage classes. Okay, now that is where the storage class comes into picture. And you have, so we have stopped in the middle, right? Automatically it will create a PV. So that means you need not create a PV. And one more thing is, when you are mentioning the volume binding mode as wait for first consumer, that means the pod, until the pod which in which you are using the storage class, so that pod has to be scheduled first. Unless it is scheduled, the PV will not be created. So that is where we have stopped right earlier. So why it is created? Because storage class will create it automatically. You may not be creating this manually. When there is a cloud provisioner, automatically PV is pinned up. So that spin up of PV happens only when the pod is scheduled, in which you are using the storage class. When you are using the volume binding mode as wait for first consumer. Now if at all you are not using this option and you used this or default this one only, then pod PV will be created no matter what pod is scheduled, created or destroyed, whatever it is, PV will be created. Okay, it will not check the health status of pod, and it will just be created. That is where you will use volume binding mode. Okay, I hope it is clear of these sections in the storage classes. So in the next section we will see about uh, stateful sets. And in this class I want to cover up to what is storage class, PVs and PVCs. So thank you so much. Bye bye.